Hello, welcome to CRFE channel. Let me introduce EMIStream, one of our PCB solutions. We've covered what EMIStream is in a separate video. This video is a tutorial guide on how to use EMIStream. EMIStream features analysis capabilities for EMI, PI, ESD, and SMPS as its core functions. In this video, we will demonstrate how to use the EMI Rule Check function and the Plane Resonance Analysis function for EMI mitigation using sample data. First, let's import the PCB layout data. Click the EMIStream icon in the upper left corner of the screen and click Open. This will open the file selection box. Since our sample data is in a design file format, please select Design File from the drop-down menu in the bottom right corner of the file selection box. In the file selection box, navigate to the demo folder under the EMIStream installation directory. Select samplewire.dsn and click Open. The PCB layout data will now open. Now, let's run the EMI Rule Check. Click EMI and then EMI Rule Check from the menu. The EMI Rule Check dialog box will open. Here, you can select which EMI rules to apply. Since we will use all available rules for this demonstration, click All On and then click Run. This will execute the EMI Rule Check. This CAD data represents a 4-layer board, approximately 8 inches or 20 centimeters square, with over 300 nets. Depending on your CPU power, the process will complete in just a few dozen seconds. Once the EMI Rule Check is complete, the layout data on the EMIStream main screen will be color-coded. Warm colors, like red, indicate nets with a high risk for EMI. Additionally, the EMI Rule Check result dialog box will open, displaying an error list for each net and component. Next, we will perform AI-driven error filtering. For the design errors detected during the EMI Rule Check, our AI, which has learned the know-how of EMC experts, will further filter the results. The filtered results will be displayed on both the EMIStream main screen and the error list within the EMI Rule Check result dialog box. For example, at the very top of the list in the dialog, you can see 27P displayed to the right of net A4. This represents 27 error points, indicating that this net has the highest error point score among all nets. Therefore, by evaluating countermeasures from the top of the list, you can efficiently achieve EMI reduction.
Let's look at the specific workflow for evaluating countermeasures. Click the plus button to the left of net A4. This will display the errors associated with net A4. Double-click the first error, trace length. The target net will automatically zoom in on the EMIStream main screen, and the detailed information dialog box will open at the same time. Looking at the dialog, it displays diagrams and text showing that the trace length is 6.552 inches, which exceeds the threshold value of 6.4 inches. A long trace length increases the risk of high radiation caused by resonance. As a countermeasure, the tool provides solutions such as eliminate excess routing path and move components closer to each other. If you determine that this design error requires modification, click the gray button to the left of the trace length error in the EMI Rule Check result dialog box to change it to red. This allows you to flag it as a required modification. Similarly, double-click Via Count on the screen to review the error details. If this error is unavoidable or you determine that no modification is required, click the gray button to the left of the error twice to change it to blue. This allows you to flag it as no modification required. In this manner, you can review each check error and flag whether a modification is required or not. For the purpose of explaining how to use EMIStream in this video, we will only review net A4, net A5/0, and component U1. Once the review is complete, go to the menu in the EMI Rule Check result dialog box and click File, Export, Create Report. The Create EMI Check Results Report dialog box will open, so click Run and then click OK on the confirmation dialog. This will generate the report automatically. The report is created in Excel format, and for the errors you flagged in red as required modification, visual screenshots of the corresponding nets will be captured automatically. Depending on the data size in your CPU, report generation takes from a few dozen seconds to a few minutes. When the report generation is complete, the report will be displayed in Excel format. The summary sheet of the report displays overview metrics, including the total number of errors and the number of flagged modifications. Looking at the net error list sheet, a list of errors that occurred on the nets is displayed.
For the errors you flagged in red as required modification during the review, screenshots of the corresponding nets are also attached. Similarly, the component error list sheet displays a list of errors that occurred on the components, complete with screenshots attached for any items flagged for modification. This concludes the operation of the EMI Rule Check.
Next, let's execute the plane resonance analysis function. Click EMI and Plane Resonance Analysis from the menu. This opens the Plane Resonance Analysis dialog box. This PCB layout data represents a 4-layer board with a power plane on layer 3. In the Display Settings section in the upper left corner of the EMIStream main screen, click the gray button to the left of 3 to change it to yellow. Layer 3 will now be visible on the EMIStream main screen. In this state, click the plane you wish to analyze for resonance. This will automatically populate the target plane fields in the Plane Resonance Analysis dialog box with layer name 3 and net name VCC. The corresponding ground plane opposing this layer 3 power plane is located on layer 2. Therefore, under the Reference Plane section in the Plane Resonance Analysis dialog box, set the layer name to 2 and the net name to GND. Then click Run. The resonance analysis will execute and the results will be displayed. On the EMIStream main screen, a color map ranging from red to green will be displayed. This represents an overlapped visualization of the resonance states between the power and ground planes across the entire analysis frequency range from 10 MHz to 1 GHz. Now, please click V-F graph in the View Resonance dialog box. This opens Excel and displays the frequency characteristics graph for the power-ground resonance. The horizontal axis shows frequency from 10 MHz to 1 GHz, and the vertical axis shows the resonance magnitude, with a line representing the upper threshold limit, referred to as the threshold voltage.
Looking at the graph, you can see that the analysis result exceeds the threshold voltage around 660 MHz. Returning to EMIStream, enter 660 into the individual frequency view field in the View Resonance dialog box and click the View button. The color map on the EMIStream main screen will update to display the resonance state specifically at 660 MHz. Red and yellow areas indicate locations with large voltage fluctuations between the power and ground planes, while blue areas indicate locations with virtually zero voltage fluctuation. We will now evaluate countermeasures to suppress this resonance. In this video, we introduce the automated capacitor placement function as a solution. Click EMI and Plane Resonance Analysis from the EMIStream menu and click Auto Place in the Resonance Analysis dialog box. The capacitor auto placement dialog box will open, so please enter C104 for the capacitor model and 10 for repeat. This setup automatically adds 0.1 microfarad capacitors sequentially and will abort the process if the resonance does not fall below the threshold voltage after 10 iterations. Then click Run. The analysis will begin, automatically searching for the most effective capacitor placement locations as it proceeds. For this demo data, the analysis completes in about 3 iterations. Once the analysis finishes, you will notice that the red areas have completely disappeared from the color map on the EMIStream main screen. This indicates that major resonances have been successfully suppressed across the entire 10 MHz to 1 GHz range. Looking at the component list dialog box, there are 2 capacitors with numbers listed in the times column. This means that 2 capacitors were added during this session. Double-clicking the capacitor with a 2 in the times column will zoom in on its added location on the EMIStream main screen.
Next, click the VF graph button in the View Resonance dialog box. Excel will open, displaying the resonance frequency characteristics, comparing the initial state, the addition of 1 capacitor, and the addition of 2 capacitors. The number 3 curve represents the result with 2 capacitors added, demonstrating that the resonance stays safely below the threshold voltage at all frequencies. Finally, let's generate the report. First, to prepare for report generation, let's fit the layout to the main screen. Click View and Zoom Fit from the menu. Then, click the Report button in the Resonance dialog box. This will create an Excel report documenting the analysis results from the pre-countermeasure state to the post-countermeasure state. Once generated, the summary sheet will display an overview of the 3 optimization iterations, showing that the result successfully changed to pass on the 3rd run after adding the 2 capacitors. On the analysis result sheet, you can review the full board resonance color maps,
the frequency characteristics graphs, and the exact positions of the added capacitors for all 3 iterations. This concludes our introduction on how to use the EMI rule check and plane resonance analysis in EMIStream. Thank you for watching.